Good morning, students. Continuing with the chapter Electrolysis, part 6. Now, today we are going to discuss about electrochemical series. We all know that metals, they can lose electrons from their outermost shell, and as a result, they make positive metallic ions. As is visible from the examples, potassium is becoming potassium ion, magnesium is becoming magnesium ion, and aluminum is becoming aluminum ions, and by losing electrons. So this tendency to lose valence electrons is not same for every metal. It varies from metal to metal. So if a metal loses electron very easily, then they are more metallic. And if the metal loses electron less easily, then they are less metallic. So the metallic element can be arranged depending upon the tendency to lose their electron. If they lose electrons very easily, so they are more metallic. So that is, if we want to make a decreasing order of their tendency to lose electrons, valence electrons, so the one that loses electron very easily will be at the top. So now this is the series what we call electrochemical series of metals. Now you can see that potassium is at the top. So this is in a decreasing order. So potassium can make potassium ions fastest among all the metals. So that is why it has been placed at the top. Calcium can change into calcium ions faster than sodium. Magnesium can change into magnesium ions faster than iron. So this series is called as electrochemical series, and in this series the metals have been arranged in the decreasing order of their tendency to make cations. Platinum, which is at the bottom, this is having least tendency to make ions. That is why it has been placed at the bottom of the electrochemical series. Now, some more points I would like to highlight. Number one, the metal with a higher position in the series displaces the one with a lower position. We know about it. Metals below hydrogen cannot displace hydrogen from acids. We know about it. Now, third, elements lower in the series. Now, this is the most important point, and it will be the most important point that will be helping you in understanding the examples. So, lower the position of the metal, faster it will have the tendency to gain electrons. That is, if you compare potassium ions and platinum ions, and if somebody asks you that out of potassium ions and platinum ions, which when offered electrons will take electrons more easily. See, potassium ion is already stable in K plus state. So it is already stable. But platinum ions, though it is stable, but it is less stable than potassium ions. So platinum ions would take electrons faster, and after taking electrons faster than potassium ions, they will get discharged first. So in very simple terms, I will like to put it across that lower the position of the cation in the electrochemical series, faster will be the discharge. So this is the first time, the lower bottom one wins the race. So cations, potassium cations and platinum ions are, if they are having competition to get discharged, platinum ions will get discharged first. Now, point number 4, metal atoms which form their ions most easily will accept the electron with greatest difficulty. So, potassium makes ions most easily, so it will accept electrons with the greatest difficulty. So, platinum, it makes ions with great difficulty, so it accepts electrons easily. Now, fifth, hydrogen has some properties of metals, that is, it can make positive ions. That is why hydrogen has been placed here, and it confirms that it's identified with the metals. Similarly, we have electrochemical series of anions also. Now, what do anions do? As in the previous video, we have already discussed that anions have to go to anode. And when they go to anode, they have to undergo oxidation. Oxidation means they have to lose electrons. Now, based on this tendency to lose electrons, the anions have been arranged in a series. This series is called as electrochemical series of anions. So sulfate, nitrate, chloride, bromide, iodide, hydroxide. So it means the hydroxyl ion placed at the bottom will be the fastest one to go and give away their electrons, lose their electrons and get discharged at anode. Sulfate ions will be losing the race. So lower the position, faster it goes. Now I'm going to speak about what is preferential discharge. See, when we talk about electrolysis, then in the system, that is in the electrolytic cell, sometimes we can have more than two ions, two cations or two anions. Now it becomes very difficult to decide that out of two cations who will be traveling faster and out of the two anions who will be traveling faster, because two cations cannot travel at same speed and two anions cannot travel at same speed. So because they are the cations and anions of different metals, so naturally they are not same, they do not identify with each other, so naturally they will not be following the same speed pattern. So now in order to decide that which ions goes first, we have a theory that is called preferential or selective discharge of ions at electrodes. Now for this theory we have to see three factors. So who will go, or we say who will win the race? Now that depends on three factors. Number one, the relative position in the electrochemical series. Now this we have already learned. Lower the position, faster it goes. Now B, the relative concentration of ions. So if in the system the concentration of ions is more, then that ion would be getting discharged first. But please remember, see, these are the rules, but when actually some experiments are done, somewhere these rules are not followed, because this is all theory. But actually when theory is performed in the lab and observations are done, sometimes some points are not obeyed and then they become exceptions. Now third is nature of electrode. Now let us first discuss the first point, that is relative position. Now you can see the copper sulfate case. Now first of all, copper sulfate is not a solid. It is in solution because electrolysis cannot take place in the solid state. So copper sulfate solution is taken, and the moment you dissolve it in water, copper ions and sulfate ions are formed. Now since you have taken water, so water also must be undergoing this ionization, and it will be making H plus and OH minus. So now you can see in the system, in the beaker, you have copper ions, you have hydrogen ions, you have sulfate anions and hydroxyl ions. Now see, there is a competition. You have two cations and two anions. Now you have to decide who goes first. Now first you compare the two cations. One is cupric and one is hydrogen. Now you very well know, according to the electrochemical series, Cu2 plus ions are at the lower position. So it is very much understood that Cu2 plus will be traveling faster because it is lower than the hydrogen ion, and it will go faster. And what it will be do, where, first of all, where it will go. Now it's a cation, and I have been emphasizing again and again that C goes to C. So cation goes to cathode, and what does it do there? Cathode reduction takes place. So this Cu2 plus will take 2 electrons equal to its valency, and it will become copper atom. That is what we call discharge. So it gets discharged, and after discharging, what happens to it? It gets deposited on the electrode. Now similarly, now let's see the two anions, sulfate and hydroxyl. Now according to the electrochemical series, hydroxyl ions should go first. Now where will they go? They are anions. So they will go to anode. Now when they go to anode, first of all, OH minus will lose its electron to become OH. Now single OH will not be able to evolve any. See, you can see OH minus at the bottom, you can see OH minus electron gives OH. Now one OH has to combine with another OH. Now then it can make H2O plus O. So one O is formed in this way. So by repetition of the same equation, one O will be formed again. So ultimately, how many OH we have used? 2 in the first equation and 2 we use again. So total 4 OH are used to make 2 H2O plus O2. So instead of writing in this manner, you can also write in the condensed form 4 OH gives 2H2O plus O2. So if this, we have to report the products of copper sulfate, dilute solution of copper sulfate, then we would be saying that our observation will be reddish brown, or you can say pink deposit. Copper is always reddish brown or pink. Both are acceptable. Reddish brown or pink deposit at the cathode, and at the anode we will have to say a colorless, odorless gas is evolved that rekindles a burning splinter. Now next factor is concentration. Now what does this factor say? See, again I am emphasizing these are guidelines, but when actually the experiments are performed, sometimes these guidelines are not followed. Why I am emphasizing? Because in the last slide one example is of such kind where this factor will not be followed. See, these are our theories, but actually sometimes it is not followed. So next is concentration of ions in the electrolyte. So if concentration of any ion is more, now for example if you take electrolysis of concentrated NaCl, concentrated NaCl means there will be large amount of sodium and chloride ions. So we NaCl, first of all it dissociates into Na plus and Cl minus, and water also it ionizes into H plus and OH minus. Now see, there are two cations, Na plus and H plus. Now who goes first? Now according to the rule, preferential, H plus go first and Na plus should go in afterwards, but here it is concentrated, so you would be thinking that Na plus will be going now, winning the race, but no. Though Na plus should have gone, but actually it was observed that Na plus is far too stable than H plus, that though it is higher in concentration, still it is far too stable to go and accept electrons and get discharge. So though the concentration of Na plus is sufficient, but still this concentration rule is not followed. So who goes here? H plus. So hydrogen gas is evolved. Now at the anode you have Cl minus and OH minus. So here Cl minus ions, they are in much higher concentration. So here the rule is followed. So Cl minus and OH minus, so we are saying that Cl minus should go according to the rule. So yes, Cl minus goes and it loses one of its electron and makes Cl which is unstable, monoatomic. Now one Cl more is formed in a similar manner. So the two Cls, they combine to become a gas, diatomic chlorine gas, and then this is evolved from the anode in the form of a greenish yellow color gas. So what I am trying to emphasize, that sometimes hard and fast rules are not followed because of some other reasons. So here Na plus should have gone and got discharged, but it did not happen because Na plus is far too stable than H plus, that even after being in more concentration it doesn't get discharged. Now nature of electrodes. See, there are two types of electrodes we often use. One is inert and one is active. Now what is inert electrode? See, if the electrode participates in the reaction and it affects the product formation, then that is called active electrode. And if the electrode does not affect the product formation, then that kind of electrode is called inert electrode. Now the active electrodes are basically metal electrodes like copper, nickel, silver. Now example in the electrolysis of copper sulfate solution. See, I am not discussing this example right now because you will not understand. Once this is our part of syllabus where I have to discuss this electrolysis copper sulfate solution in detail. That time it will be clear. So this example part you leave and we will discuss in the upcoming topics. So basically, if there are two types of electrodes, inert and active. If the electrode does not participate in the reaction and does not affect the product formation, that is inert. And if the electrode participates in the reaction and it affects the product formation, then that is active electrode. Now see this table, this is there in your book also. Now dilute copper sulfate solution. Now dissociation, it takes place. So ions formation, cupric ions and H plus ions. So Who will be going first? Cupric ions will go to cathode and get discharged as copper metal, and it will get deposited, and out of the two anions the hydroxyl ions will be going 4 OH minus 4 electrons gives 4 OH. There in the previous slide it was shown in steps. Now here it is being shown in consolidated form. So this 4 OH gives you 2 H2O and O2. Now if you take dilute NaCl and concentrated NaCl, see, compare this. You should compare this. Now when you take dilute NaCl, it means sodium ions and hydrogen ions are there, and in case of anions you have Cl minus and OH minus, so it's dilute. So H plus will win the race and it will be discharged as hydrogen gas, and out of Cl minus and OH minus, hydroxyl will win because it is at the lower position. So oxygen gas will be evolved. But in the case third, sodium ions should have won and got discharged. But in the previous slide also I told you it is far more stable, that it can't go and get discharged in spite of the fact that it is in a higher concentration. So still H plus wins because of a different reason. And in the anions, Cl minus and OH minus, so since chloride ions are in more concentration, so they get discharged. So basically the difference in reaction or your observation will come in your anode observation. So if they ask you that write the observation at anode when dilute NaCl is electrolyzed, so you should say oxygen gas, that is a colorless, odorless gas is evolved that rekindles a burning splinter. And if they ask you that write your observation at anode when concentrated NaCl solution is electrolyzed, then you should say a greenish yellow color gas will be evolved. So I hope it is clear. Please underline the observation or this part of the table, reaction at anode for dilute NaCl and concentrated NaCl. So that will be all for this topic. And topic means this part, that is preferential discharge, and we will be continuing further. Thank you.